Very good morning, everyone. Good morning, everyone. Hi there, can I get your attention? Thank you. Good morning, everyone. Thank you for being here. My name is Daniel Wood. I'm a Master Mariner, Head of Ports and Harbours Governance at ABL. 35 years in the industry, 20 years at sea, and 13 of those on cruise ships. Our briefing this morning is accredited by the Chartered Insurance Institute, and delegates can claim up to 1 hour CPD for your participation. We will therefore keep a record of those of you in the room today and those of you who are logging on online. If you hadn't done so already, please make sure you sign in with the team on the desk outside after the briefing in order to be able to receive your follow-up email and CPD certification. Just a quick reminder today as well, we will be ending the webinar portion of the briefing after the technical presentation, and the marine casualty case reports moving forward will only be presented in person. Of course, we are happy to discuss with anyone who would like more information on them post-briefing and to look at how we can make the data available to you. So please come and see me afterwards if that's something you'd like to discuss. I'm delighted to introduce our technical speakers for this morning's session. First up, many of us, of course, know Mark McGurran, ABL's Global Managing Director of Maritime, and also a good friend of mine. Usually, Mark leads the introduction and conclusion for these briefings, but today he's taking the stage as our technical presenter to share his expertise on passenger ships, a technical perspective. With over 25 years in the maritime industry, including 12 years at sea, Mark has first-hand experience across passenger, container, high-speed and offshore vessels, rising through the ranks to chief engineer. His career spans marine consulting, casualty investigation, and warranty services, giving him a comprehensive technical understanding of passenger ships from both operational and risk perspectives. It's great to have him delivering today's presentation. And to read this month's case reports, we are also delighted to have Stanley Pritchard. Stanley is a mechanical engineer on the ABL Group Engineering Development Scheme. He currently works for Longitude Engineering, and we are equally pleased to have him this month present our marine casualty data. Please note today that the usual caveats apply. Chatham House rules apply fully. Please also remember that the information contained in today's presentations and any opinions or comments expressed are those of the presenters and not necessarily those of ABL. At the end of today's briefing, can we please ask everyone to take a 3-minute time out of their day just to complete our online survey? This is really critical for us for our CPD accredited status and allows us to offer you 1 CPD point per briefing. It also means we can actively look how we can improve these briefings to match your requirements and needs. Please use the QR code on the screen or displayed outside the room to download the survey. And don't worry if you miss it, we will also send this to you in our follow-up email. Before I begin today, we ask you to give a few moments thought to seafaring men and women at sea. Even though COVID-19 seems to be increasingly in the rearview mirror, we know that seafarers are still working often longer than they are meant to due to crew change issues. There are also, of course, a multitude of other factors going on in the world which impact adversely the lives and conditions of seafarers. Many of our own colleagues come from seafaring backgrounds, so crew welfare is a cause that is very close to our hearts. As such, ABL are a signatory to the Neptune Declaration, which has undoubtedly played a part in many improvements to the lives of seafarers today. Please take a moment to look into this and perhaps consider getting your own company to become a signatory. So onto our learning objectives for today. You will gain an understanding of the evolution of passenger ships. You will be able to describe the technological advancements shaping the current passenger shipping industry. You will be able to identify the primary risks associated with passenger ship operations. And finally, you will gain insight into what the future holds for passenger ships. We will go over these again at the end of the presentation. And now, delighted to ask Mark to come up to stage for today's presentation. Thank you.
Thank you, Dan, and welcome everyone here today in person and online. So we start off with what is a passenger ship? Like all ships, it carries things from A to B between ports. Ferries often operate on a scheduled route, so arrival times and departures are fixed. In general, the cargo for a ferry has to be delivered on time, but of course for cruising and yachting and pleasure passenger ships, there is no real reason other than the enjoyment of those on board to get from A to B. So we can be slightly flexible with schedules and timings. So the cargo, it's not secured or lashed down like many cargo ships. It likes to be entertained, to shop, eat and drink. You get young, old, large and small individual cargoes. Some of the cargo likes to smoke and flick their cigarettes over balconies. The cargo reacts very badly to water and fire. The cargo may be litigious, especially in certain parts of the world. The cargo may also include the cargo's own transport and sometimes pets. And it may be mixed with other cargo types. So we're dealing with a very volatile cargo, perhaps the most volatile of all. So under SOLAS, passenger ships are designated as a ship which carries more than 12 passengers. Interestingly, the reverse of that is true. A ship that carries less than 12 passengers is not a passenger ship, and therefore you can legally and rightfully carry passengers on cargo ships if you have less than 12. And there are some ocean-going cargo ships that offer these cruises, in inverted commas, to passengers who've fed up with the conventional cruising. Ro-ro passenger ships contain ro-ro cargo spaces or a special category of spaces. They're defined differently under SOLAS because they are not subject to the same watertight compartments and separations that define passenger ships under SOLAS. We'll come on to that a bit in a minute. There's lots of different types of passenger ships. Cruise ships, passenger ships often get used interchangeably. Cruise ship and ocean liner often get used interchangeably. They're both types of passenger ships, but there is a difference. An ocean liner is a ship designed to transport passengers from point A to point B and not to cruise around from a tourist angle to visit lots of places. After RMS Queen Elizabeth II was retired in 2008, the only ship still in service globally as an ocean liner is RMS Queen Mary II. And of the many ships constructed over the decades, only 9, I think now 8 of these vessels constructed before 1967 are still around and not in service. Most of them are moored up in various ports as hotel ships or as entertainment venues. Obviously, there's lots of variations of these vessels above, and they don't all fall into defined categories when it comes to regulation. So if we look back at the evolution of the passenger ship, it's split into 2 categories, really, as I say, cruise ships and ferries. Starting with cruise ships, they were born from the ocean liners, which in turn evolved from the steam packet lines in the early part of the 19th century. From these came the first transatlantic liners, which usually included a cow on board to provide fresh milk. Obviously, things have changed since then. Then came the period of the great ocean liners, and a bit of Anglo-French competition, which we don't mind, began for size and speed and opulence of the liner. We'll come on to size in a bit. There's some interesting points there. And then along came long-distance air travel, and it didn't just affect the lovely seaside towns on the south of England, it affected the passenger ship industry as well. And instead of the primary focus being taking passengers from A to B, moving people to the New World who immigrated, or people who were traveling between Europe and the US. It moved to a leisure industry, a tourism industry, and then we moved to modern cruise liners or cruise ships. So these changed in design and they changed in their purpose. Their hull forms changed because their role was not to punch through any weather at speed and efficiency. Their role was to move comfortably in usually benign weather, because if the weather gets too bad, generally they don't go there. So they had much shallower drafts, much flatter bottoms, and didn't have such a fine hull form. Obviously, this has moved on. Vessels have got bigger and bigger in recent years. So if we look at the evolution of a passenger ship, obviously, some famous ones here. Not all of them still afloat. The Titanic, 269 meters long, so still quite a long ship. Not that small, with a total souls on board of 3,327. Obviously, moving very quickly on through the years to the Costa Concordia, she was 290 meters long, so only 21 meters longer than Titanic. So in length, not a significant size difference, but in gross tonnage, significantly more, approaching 3 times the gross tonnage, and had over about 1,500 more souls on board, so 4,780 compared to Titanic. We move on to the real modern, the very larger ones. Allure of the Seas, 2,225 gross tons. We're now at 362 meters long, so almost 100 meters longer than the Titanic. 8,980 total souls on board. So we've had not insignificant increase in size, but I think you can appreciate that in length, but the capacity for carrying has come from making these vessels much larger, not just much longer. So they're much beamier, they're wider, and they're much more high-sided, which I'll let Dan talk about that. But for manoeuvring, of course, in wind, that can be an issue. And their passenger capacity has increased exponentially. We now move on to the largest of all that's in operation today, the Icon of the Seas, 2,225 gross tons, 360 meters long, 9,950 souls on board. Why they couldn't find space for an extra 50 and call it 10,000, I don't know, but they haven't. I'm sure somebody else will come along with a vessel that's bigger eventually. Importantly, the important statistics, 7 pools and 6 water slides. Again, that messes with my OCD. If you've got 7 pools, you have 7 water slides. But anyway, 20 passenger decks. So compared to the Titanic, significantly higher, a significantly higher air draft. And as is becoming the case now, we've seen 10 years ago, more and more balcony cabins on cruise ships. Now we're seeing inboard balconies as well, because that's what the customers are demanding. So a real change in the design and scope of the vessels that we're seeing. I'm not an insurer, but I think there might be an angle here for aggregated risks of having these things in the same place at the same time. And obviously, given the seasons, they do operate in the same place at the same time. As I said, they're not there to transport the world's commercial cargoes from A to B. So when the weather's nice, they're in the Caribbean, and in the summer they come back to the fjords or to the Mediterranean. So they tend to all congregate in the same place at the same time. So the values we're talking about in one place in one time can be quite significant. Just a brief bit on statistics. I won't go on too much about this because this tends to bore people and many of them aren't particularly accurate. But we can see that the cruise ships, the passenger ship statistics make up approximately 11% of the world's fleet. 11% of the 6.5% are defined as cruise ships. My mistake. So 6.5% of the world's tonnage are passenger ships, and 11% of those are cruise ships. So cruise ships is actually a relatively small portion of the world's fleet in tonnage, but make up quite a large portion of the new build cost and presumably then the insured value of the world's fleets. This is passenger numbers in millions. I don't know what happened in 2020 and 2021, but there was some sort of dip in the world's cruising industry. But what we can see from this is recovery was very quick and the graph still trends very much upwards. There was a time, 90s, probably early 2000s, where I think cruising very much fell out of fashion, when it was still considered, staid and for old people and for ballroom dancing, as Dan and I were taught to do to entertain the passengers. But that's all changed. There are many different brands out there offering many different products to lots of different sectors of society. So it is a very, very popular holiday option, and we continue to see the industry and therefore the new builds increasing. This is from our own data, from ABL's data. Obviously, I have to caveat this that we don't have all of the market's data. I don't know why that is. Perhaps we should get more instructions. But we do have a large portion of it. And this graph has changed significantly in the past 10 years. 10 years ago, passenger ships would have been down around the $1 million mark for their average claim. They're now the highest on this chart, and that is predominantly due to the cost of repairs to ASIPods, which I'll speak on about briefly in a moment, and also some of the high cost damages we've seen of them being blown off or blown onto berths and causing significant maritime civil damages to port infrastructures. So what are the risks? We'll have a quick look at a typical passenger vessel and what we should be looking for. First of all, as I've mentioned, there's potentially thousands of people on board. That's thousands of people that need to do as they're told and need to act correctly. And obviously the risk of that is quite high. And we do see a lot of damages. We see a lot of claims, slips and trips from the P&I side as well, from crew and from passengers on board. There are large fire zones, much larger fire zones than we would ideally like from a fire containment point of view. And this is because of the new design of cruise ships. We see very large atriums, we see very large spaces and theatres and cinemas, which are all designed obviously for the design ethos of the particular sector of the market the cruise company is going after, but they're not really helpful from a fire containment point of view. Obviously, from a fire and a watertight containment point of view, you want as small a space as possible. Cruise ships themselves don't tend to have a problem with watertight containment because most of the area below the blue boot topping there is crew and machinery and operational areas, so we don't have to worry too much about that. So they do tend to get compartmentalised rather better than the passenger areas. Evacuation of these thousands of passengers is also an issue, of course. The SOLAS requirement is that the vessel be evacuated in 30 minutes. That doesn't go up with the size of the vessel. So if you've got a ferry which has 50 people on board running between Southampton and the Isle of Wight, you've got 30 minutes. And if you've got 9.5 or almost 10,000 people on the Icon of the Seas and you're in the middle of the Atlantic, you also get 30 minutes. I'll speak about it in a bit. Those of us in the room with passenger experience know this is very difficult to achieve. Obviously, the complexity of these vessels as well. There's lots of very high tech on board, lots of IT. So we've got big cyber risks coming into play now, as well as just the complexity of the machinery that's on board. Lots of different types of machinery, far more than you would see on a cargo ship. Bridge operations obviously have their own unique risks, which Daniel will talk about a bit later on. So survivability, damage control. As I said, different regulations on a ro-ro ship, but for passenger ships, they do have to have watertight compartments. And perhaps the scariest aspect of a ship of this size, with this much of it above the water, is stability and obviously the need to evacuate if something goes wrong. The rules for damage stability to passenger ships and the return to report requirements are more stringent than any other vessel types and require a minimum attained level of survivability based on the probability of a range of damage scenarios occurring and the ship surviving them. But this problem is amplified by the sheer number of people involved. As an example, the Estonia disaster cost the lives of over 800 people, and we've seen much higher passenger numbers, which I'll come on to in a bit, having lost their lives and other issues. Obviously, Costa Concordia, well known to this industry, well known to the cruise industry, as an incident that should not have occurred and that cost lots of people lots of money, and unfortunately some people their lives. As I mentioned, it requires a full evacuation in 30 minutes, and it's a massive task. With vessels heeling at an angle, as you can see here, it's very difficult to launch or utilise the life-saving equipment on board and the evacuation equipment on board. Although obviously Costa Concordia was a terrible incident and people did lose their lives. In my opinion, I think it's quite impressive and a bit of a miracle that many people did get off that vessel. Over 4,000 people managed to evacuate that vessel safely. So that was something which I think, given the angle of the vessel, many people thought wouldn't have occurred. The importance of crew training, ISM procedures, and systems drills and familiarisation of the crew cannot be overstated. This is naturally taken very seriously by ship owners and operators. And of course, since this incident, the regulations have changed on when you have to have passenger drills within a certain time frame after they've boarded the vessel. There have been tragic incidents of loss of life even during drills, and we've seen these marine escape systems cause the loss of life of volunteers who, when you do a drill, obviously you need to fill the vessel up with however many passengers you have. We've unfortunately seen injury and loss of life of passengers who have been evacuated under drill conditions, not under real life emergency conditions. So you can imagine the panic of 10,000 people when they're trying to evacuate. These are all things we need to consider. We've also seen, both in real life tragic incidents and even in drills, passengers / volunteers hiding away in cupboards and in cabins as opposed to doing what they've been instructed to do, just due to the nature of panic. So, as I said, very volatile cargo, and they don't always do as they're told, even in emergency situations. Even when you have all of this equipment on board, these marine escape systems, lifeboats, life rafts, things obviously don't usually go wrong when things are benign. Things tend to go wrong when the weather's at its worst. And in this instance, we had to airlift 479 passengers off by helicopter overnight. The vessel lost power. When a vessel loses power, it is unable to steer or power itself into the weather, so it is at the mercy of the weather. This vessel was simply moving too much that it could not use its lifeboats, its life rafts, or its marine emergency systems. So we can see that in an evacuation scenario like this, things can get quite treacherous. And even, of course, the use of helicopters is not without risk, especially when a vessel's moving this much. So machinery damage. There's a lot of machinery on a cruise ship or a passenger ship that isn't in use on an ordinary cargo ship. When I started my career in marine surveying, we did a lot more hull and machinery attendances on passenger vessels than we do now, even though the cost of the ones we attend now has gone up. And that primarily has been driven by the increase in deductibles and aggregate deductibles, which are being applied to cruise ships because of the complexity and the cost of the equipment that is involved. So we have multiple generators, large electrical systems. We have a hotel electrical load much higher than we would have on any cargo ship. So this all needs to be provided for. Many cruise ships these days are effectively floating power stations. And most of the propulsion is diesel electric, which I'll come on to in one form or another shortly. Maintenance of that equipment is a major focus. And of course, with these systems being so complex and requiring so much maintenance, this gives the opportunity, unfortunately, for things to go wrong, either if that maintenance is missed, or as we often see, when the maintenance is done in good faith, but it is done incorrectly, and then we see failures following that. They tend to have newer technology. They're at the cutting edge of marine technology. Cruise companies are always looking for a way to differentiate themselves from the competition. So they're very keen on investing in new technology. We do see new technology, higher power technology as well. A lot of cruise ships use gas turbines to generate electricity because for their size, they're able to generate more power. So then you save space within your ship for more coffee shops and ice cream parlors. We've even seen tattoo parlors on cruise ships. You don't want to know my opinion of that. But saving space within the ship is how they generate revenue and how they generate their income. So we see higher powered, smaller units in use, which by their definition are harder to maintain. The tolerances within these bits of machinery are more critical. So we see quite expensive damages coming from them. And being new technology, of course, there are often teething issues. And once these technologies enter service, unfortunately, the ship owner and therefore their insurers end up forming part of the R&D department unwittingly, I think. Firefighting with such a high value and litigious cargo is of paramount importance, and the systems can be complex due to the passenger spaces and the complex subdivisions within the ship. Most modern cruise ships are fitted with the very best and the most modern firefighting equipment. I've taken UK-based firefighters on board cruise ships to show them round, and they've always been impressed with the kit that's on board. Of course, that's only half the story. The other half of the story is who's going to be using the kit, which I'll come on to in a bit. Feeding thousands of people requires a large, complex operation and very large galleys. And galleys have associated fire risks. And some of the machinery in these galleys is, really is of an industrial size. We see many cruise ships with escalators in their galleys, revolving doors, very large pot wash equipment, all sorts of equipment that presents possibilities for mechanical failure, but also possibilities for fire, obviously. So we have to be very sure that our ranges and our exhausts in galleys have the correct fire suppression and fire detection systems. As I mentioned before, the requirements for damage stability and return to port are much more stringent for passenger ships. Everything's getting bigger ship-wise, but ports are getting smaller. As I said, these cruise companies try to find ways to differentiate themselves. They move to smaller, more exotic ports, which obviously gives the opportunity of higher risk, because manoeuvring in these shallower, narrower ports and waterways gives the opportunity for collisions and groundings, and the locations are more extreme and more remote. So when incidents do occur, responding to them is trickier. The growth, obviously, in cruising in areas such as the Antarctic has been going on for decades now, and it's a very popular destination, but it comes with its risks, both environmental and technical. So, as I said before, the bigger ships, heading up 9,000 and more, the drive to find new and interesting places to have these cruise ships visit. And if we're talking about some really environmentally sensitive areas here, so there's significant risk involved there. And arriving in these places from a local social and environmental point of view, when you're adding 10,000 people to a location which usually has a few hundred or low thousands, has a large social impact as well. There is a real drive towards cruising to less accessible places, so we expect to see these risks increase. And Arctic, Antarctic, places where ships really haven't been before. And it involves a specialist problem dealing with ice and what happens in an emergency if we have an emergency in these regions. Being different as well is becoming a primary driver, say inside cabins, climbing rules. I mean, from a risk point of view, the mind boggles. Having hammocks on balconies is becoming quite popular, even though you can swing on them. It terrifies me, but this is what's going on, all in an attempt to attract more and more passengers to come and cruise with them. We've seen unfortunately a few cruise ships lose stability, and we've seen some sink, of course, in the Mediterranean. We have seen successful evacuation. We have seen some, unfortunately, which haven't been quite so successful. Moving on to fire, I think from a seafarer's point of view, fire is probably one of our greatest risks. If it's not controlled immediately, it can spread rapidly and become catastrophic. And of course, the cost of repairs can be very large indeed. Smoke, even in areas where the fire wasn't seated, can cause significant cost of damage in other parts of the vessel. Passengers like to smoke. This is the result of a passenger smoking on a balcony. They say that it was hot ash from it blown overboard, as opposed to the cigarette being flicked overboard. We don't know, of course. But because of the need for open spaces, atriums, theatres, car decks, as I said, the fire zones are very large, so it's very hard for us to compartmentalise and shut them down very quickly. So careful consideration needs to be given to fire zone design, right at the design stage of the vessel, fire detection and fire control systems. For example, CO2 extinguishers are very effective, but tend to be a last resort and only kill the fire and have a tendency to kill anything else in the area that's human. So we have to really consider what type of systems we're going to use. Are we going to use high fog? And detection as well is a really important part of it. Early detection and the requirement to respond to that detection quickly is paramount in controlling these. Unfortunately, the type of people that have to operate all of this wonderful fire kit we've got on board are seafarers. There's a couple of ABL surveyors in that photo. I won't point them out. Maybe you can do so later if you want a copy of it. But this is us paying a great deal of attention. I've just said us, so you know I'm in it, never mind. Paying a great deal of attention during our firefighting training. So you can imagine sometimes the panic that ensues when we do have significant fires on board. So moving on to complex technology and new technology. As I said earlier, passenger ships, cruise ships often encompass new technology quicker, and they adopt it quicker than the rest of the industry. The take-up of so-called ASIPODs. Now, ASIPOD is a trade name word from ABB, but many people in the industry use it to mean any azimuthing or rotating propulsion pod, which is usually underslung of the vessel. Has many potential benefits: maneuverability, saving space, station keeping, so you can go in a shallow draft cruise ship with ASIPODs to one of these sensitive ports where previously, if you've had to drop an anchor to run tenders, you wouldn't have been allowed to go to because the environmental damage of dropping an anchor on a reef or on a sensitive area. So you can hold station with your ASIPODs and you can run tenders ashore. However, this new technology, although it's not that new anymore, but they are constantly developing, has issues where we've seen failures arrive, both mechanically and electrical, leading to numerous claims of significant cost. Obviously, the cruise ship industry is committed to this because it really serves them their purpose in terms of maneuverability, in terms of the effectiveness of the vessel, and as I mentioned before, in terms of saving space inboard. These large electric propulsion motors are not within the vessel, they are outside of the vessel. So the electric motor itself is within the pod and it is driving the propeller. This, as I said, allows more space to be saved on board inboard the vessel that we can sell for revenue. The downside to these rather complex bits of kit being slung under the vessel in the water is, of course, that if they fail, you have to take the vessel out of the water to repair them. You can access them from inside the vessel, but you can't really change much of the kit that's down there. And if anything significant fails, bearings or stators or rotors, you have to get the vessel out of the water. This is a vessel we did near the Bahamas a couple of years ago, and there was no dry dock in the area large enough to take it due to the failure of Grand Bahamas dry dock just 6 weeks prior. So we had to charter a heavy lift vessel to get the cruise ship out of the water to repair the pod. The cost of doing this was akin to the cost of the actual repairs, so significantly more than the dry docking costs we would have expected previously. They're not just complex. In a lot of the technology we're using now, especially when we're visiting environmentally sensitive areas, requires that we don't run the engines or the generators on board. So we use shore power, which we call cold ironing. So this diagram hopefully gives you an indication of how complex these systems can be. But we can plug into shore power when we're in these ports, so we don't create any atmospheric pollution when we're powering the vessel when we're alongside. The future, perhaps, LNG as a fuel, we're seeing that come out a lot. Fuel cells as well. It is clean, but it requires different systems and again, different expertise, and will be at the cutting edge. New machinery arrangements, as I've mentioned. Design of vessels starting instead, as ocean liners did, with the external form of the vessel. They're now starting with the internal form of the vessel. And will they get bigger still? We're not sure. There's a lot of niche vessels around, some on the drawing board, some being constructed. This is an LNG-powered expedition cruise ship. It's the first ice-breaking cruise ship. It was launched in 2021. My French isn't good enough to pronounce the name, so I'm not going to try. It's fitted with the ice-class ASIPODs. We have hybrid vessels around as well, which are ice-class but not ice-breaking. So these obviously present particular risks. Social media, or media as such. Obviously, the one on the right wasn't social media, it was media, but it's always been an issue for passenger ships. as we've seen over the years, when something goes wrong with a passenger ship, it grabs a lot of mainstream press attention. From the Titanic being touted as in the press as unsinkable, the saturated media coverage of the Orange Hereford Enterprise lying on its side in Zeebrugge Harbour, and unfortunately 193 people lost their lives. That was all over the news in 1987, for those of you that remember. The same year, the Donna Paz sank in the Philippines with a loss of 4,386 lives and didn't make the press at all, really, in Northern Europe or in Western worlds. So the press does have an influence on the perception of the industry. Obviously, with cruise ships, most of the passengers on board these days have their own means of distributing press with their mobile phones. So we see a lot of things popping up on Twitter before we've been informed. A vessel called the Something Epic crashed into the berth, and hashtag epic fail was trending very shortly afterwards. In the long term, we might see floating cities. We might see ships where people are living upon. There's a lot of concepts kicking around based on the drawing board not being built yet. But there are cruise ships around where you can effectively buy apartments and live on. As for ferries, it looks to the future of ferries. We're looking at electrification for longer routes, which again has issues with lithium-ion batteries, which I think many of you heard me speak about perhaps a bit too much. And again, with ferries, we're seeing some get bigger, some get smaller for smaller ports, running into ports that perhaps we weren't running into before. I'm now going to hand over to Daniel. Daniel and I are both in this photograph. So you can tell it's not only cruise ships that have got bigger in the past 25 years, it's also their surveyors. Thank you.
Thank you, Mark. I think the biggest risk has been to my hairline since then. I think that was, what, 25 years ago?
May 2020.
Yeah. So going to talk a little bit about bridge operation risks now. Firstly, I'd like to focus on navigation and collision risks. So probably the key thing that we hear everyone talking about is human error, and how human error is a cause of 80% of the incidents that happen on cruise ships. What do we mean by that? And this can mean sort of misinterpretation of what's going on the bridge. When I first went to sea, we had 2 bridge officers, and I think on that ship, in the picture before that we were on, was the old Arcadia. We had around 1,500 passengers. It's still the same bridge team for 9,500 passengers, so 2 officers up there. And you can receive numerous phone calls during the day. You'll be responsible for monitoring the fire alarm system. So all those fire alarms going off, people phoning you up about closing swimming pools, someone about a passenger complaint that they can hear something banging. And so this is really a huge sort of burden on the officers on there. And officers can then become distracted and can end up having lapses and making mistakes, or having miscommunication between the team. Also, traffic management is a big concern. Obviously, as the ships get bigger, more difficult to maneuver when they're going at high speed. As Mark spoke about, they're very sort of high-sided. So you'll see cruise ships trying to take very early action to avoid situations, but that's not always so easy in congested waters. And particularly with new itineraries, we're going to the ship's going to some weird and wonderful places with lots of local traffic that doesn't tend to operate according to the international regulations for preventing collisions at sea, the coal regs, and that can be quite problematic for the officers on board, leading to collision risks. Also, equipment failures as well. As Mark said, technologically, the engine room and spaces are becoming very advanced, but so are the bridges. And you can see there are a multitude of screens. They work on these sort of multifunction screens, but they can be temperamental and fail. And this leads to loss of situational awareness and can lead to errors. So how do the bridge teams overcome this? They practice what they call bridge resource management. And this is part of the training now. So basically what this does is it emphasizes teamwork amongst the bridge team, ensures clear communication. They do what they call now closed loop communication. So you give an order, someone repeats that, and then you say yes. So you're closing that loop, which is really quite a sort of a new thing, and takes out all those communication issues between the teams. It allows the team to have shared situational awareness, so going to a shared objective and goal, and the decision-making then becomes coordinated to prevent errors and enhance navigational safety in all conditions. It was taken as best practice from the airline industry around sort of 20 years ago, and cruise ships have really sort of built on that. But as I say, there are sort of limitations because of the increased pressures on the officers due to the size of the ships and the amount of people on board. What about heavy weather then? Inevitably, passenger ships will encounter heavy weather. As Mark spoke about the different seasons, they've got to move between areas for these seasons. That generally happens in what we call shoulder seasons, so when the weather's changing. Most conditions can be coped with well. Most ships have stabilizer fins, and these can reduce roll by up to 80%. So if you were rolling 5 degrees, which is the sort of general limit for passengers becoming a bit unstable, stabilizer fins will reduce roll to probably less than a degree. So yeah, just over 80% efficiency. They do affect fuel economy. So, some captains will be quite aware of that, and because they'll reduce speed by up to half a knot and, maybe a reluctance to use them. But in some cases, they can actually make the ship more efficient with following seas, can increase speeds and efficiency. Of course, vessels can alter to minimize effects, but generally they have an itinerary to prosecute and get there with lots of shore excursions, lots of commercial pressure. They could wear the route, but oftentimes they don't. So if the ship encounters heavy weather or storms, there is a large propensity for damage to superstructure. As you can see there, the windows are very far forward. Because of these expensive fit-outs, any sort of damage to the forepart of the vessel with the windows becoming stove in can lead to very high claims. Obviously, you have an older clientele, a lot cruising, who can be a bit unsteady on their feet. And if they are located in cabins not near low down or midships area around which the ship moves relatively lightly, if they're up forward, high up in the ship, there can be a lot of movement and leading to sort of slips, trips and falls, which is the biggest source of claims on cruise ships for personal injuries. In the case of ferries, this damage may extend to the cars and trucks as well on board. And with the UK-France cross-channel ferry service, no.
Apologies, everybody, just trying to get this back up. Display that.
There we
There we
go.
go. And let me just reshare. You got it on the screen. Sure. Got it there?
Got it? Great. So talking about thanks for your patience there, sorry about that. So we're talking about cross-channel ferries. So ferries on the France-UK route, often designed now to work in and berth in winds of up to 50 knots. So rough weather is somewhat more of an occupational hazard. It's important to note as well that many passenger ships operate in areas with tropical revolving storms. Obviously, they like to be in the tropics chasing the good weather. For example, now on the 1st of June, we're approaching obviously the Caribbean hurricane season, which runs until November. And that's obviously a major cruising destination. This image actually shows typical hurricane tracks in the Caribbean. Obviously a clear risk. It's one that cruise lines take very seriously, but it does increase the potential for heavy weather and the risks that involves. So this was on a ship I was on in 2003. So sometimes the best planning can often not be enough. We were on Australia, New Zealand cruising, and we just left Hobart in Tasmania to cross the Tasman, heading for the fjords on the west coast of New Zealand. We were out of port for around 12 hours, flat clear, and tropical low came through just out of nowhere. The picture on the right is us actually hove to, so we couldn't turn back. It was too dangerous for us to turn back. So we just basically stemmed the weather at 2 knots and basically slammed like that for 12 hours, wrecked the ship, wrecked the passengers, and there was nothing else we could do. The picture on your left is us coming into Fjordland, actually about to pick up the pilot. That was taken from the pilot vessel. So there was still 6-meter swells after taking, 9-meter swells in the Tasman for 24 hours. Not very nice at all. So we didn't make Fjordland, and we went through the Foveaux Strait and went into Port Chalmers, which was our first port of call. And if you know Port Chalmers is the port for Dunedin. And if you know Dunedin, you will know, and you know rugby, you'll know that that's called the House of Pain. And a couple of days later, I was doing a presentation for the passengers, and a very smart Australian passenger came up to me and said, funny how your first port of call was the House of Pain after 3 days of pain at sea, and we didn't make Fjordland. So he thought that was great. But there you go. So yeah, lots of lost revenue. Obviously, we missed the best part of the cruise, and we didn't. We spent 12 hours just trying to ride it out. So when we come into port, we have maneuvering risks as well. Obviously, we take on board a pilot who helps to guide us in, because we're closer to things that can sort of hurt us, and we take tugs as well. But as well as being sort of mitigators of risk, this also requires more intense bridge team management, working with these new people. So that involves bringing in risks as well, and leads to our biggest risk moving into port is obviously contact damage. So striking docks, and a lot of the infrastructure now is aged, particularly around the UK. We're looking at infrastructure that was built by the Victorians. And so when you touch on that with a very big ship, it doesn't last very long. This can lead to claims, obviously, for the ship, for the port as well, and putting the port out of operation. So it's very important that we sort of coordinate well with all the services in there to get the ship in safely for passenger ships. So this was another example when it doesn't go right coming into port. So I think this was in 2003, and we were coming into Kusadasi in Turkey. And we opened up a nice 3.5-meter hole in the starboard side of the ship, and really only lightly touched on a bollard at the end of it. Happy. Touch anything.
Yeah, I did just touching.
Okay. Great, thank you. Apologies for that again. Yeah, so touched on very lightly on a bollard and opened up that. Very sad for the crew because I was in the crew bar. So the crew bar was out of commission for a few nights. Fortunately, the vessel had a coded welder on board. They were doing another job. The vessel managed to buy some steel from a Turkish scrap merchant. Very good, nice and cheap. That came on by tug in the dead of night. And they put that patch on and interim certificate of class to go to the next port of call. But unbelievably, that patch actually lasted for a whole season in Antarctica. The ship managed to go down there. I don't know if I'd be on that. I got it from Cape Town, but apparently they survived. So yeah, when it goes wrong, this is what can happen. So I go to the floor now and just open up and ask if there are any. No. Okay. So yeah, if you can email your questions through, for those of you online, just email them through and we'll be do our best to answer them for you. So So just a final recap of the learning objectives for today. So you'll have gained an understanding of the evolution of passenger ships. You've been able to describe the technological advancements shaping the current industry. You've been able to identify the primary risks associated with passenger ship operations and gain some insight into what the future holds for passenger ships. So this concludes this month's ABL Maritime Market Briefing for those of you who joined online. Our next market briefing will be on the 10th of April. Thank you for joining. Hope to see you again. And over to Stanley for the case reports. Thank you.